Hello, everyone. My name is Maurizio Vitale. I'm technical lead with Frisco, and I'm based in London. And today, I would like to talk to you about Angular Tensorflow.js. This is the agenda. I will start by giving you an overview of the problem that we are trying to solve, that is search images by content. Then we will see how Tensorflow.js can help us to fix this problem, and after that, I will show you a demo of the final application and how to code it. Searching is the most popular activity users do on the web. These are the hot trend keywords coming from Google Trend. As you can see, people are searching for football teams, celebrities, and recent events. But when it comes to searching for images, it is the content within the image that people are more interested in. For example, which object do you recognize in this image? Well, there is a chair, 2 bottles of sauce, a dinner table, and a sandwich. Each of these objects can be represented in a JSON format. And this is how we store it. We have the position of the object, the name, and the score. The score is a value between 0 and 1, which indicates how likely the model, how likely the object represents that particular class. For example, in this case, the model is 0.76% sure that that object is a sandwich. But if we take one step back to the previous image, we can see that thanks to our brain and ability to recognize objects, we were able to add this metadata manually. This is a really difficult task. And as a developer, you can imagine that probably you will need hundreds of thousands of lines of code to make a computer able to recognize this with a traditional approach. But what if there was a different way to teach a computer how to recognize what it sees? What if you could make a computer learn in the same way a human does? This is the core of machine learning, and this is where Tensorflow.js comes in. Thanks to a pre-trained model called Coco SSD, we will be able to automate this process. I already mentioned one pre-trained model that is called Coco SSD, which is able to detect 90 different classes. But there are other models available out of there. Let me show you a couple of examples. There is MobileNet, which is optimized for the mobile. This means that the model has less parameters, so then the predict phase will take less time. Another one is BodyPix, which is able to detect the pixel of the body, so then you can remove the background of those segmentation. And the last one that I would like to show you is PoseNet, which is able to detect the joints of your body. To be able to use this model, you don't need to know anything about machine learning, but you just need to load it and use it. During this talk, we are going to use the first one, Coco SSD. Of course, with the Tensorflow.js, you can even create your custom model. And if you are interested in such a things, I can recommend you a couple of videos from Lauren and Asim. Now that you have a roughly idea what you can do with Tensorflow.js, let's see in more details the problem that you are trying to solve. Imagine having a repository with thousands of images with useless name. As a user, you know the content that you are looking for example, a cat, but you don't know the file name. So you write cat in the search, and you see that the result page doesn't give you any results. This is because there is no metadata that contains such info. And to avoid this problem, what you could do is just edit the description field and add this information there. And if you try again, you can see that the image now is there. But because we don't like to do manual stuff, let's build our own Angular application that uses machine learning to automate this process. These are the steps and library that we are going to use during our, inside our Angular application. Just to give you a quick overview, starting from the left, we have Google File Storage, which is used to upload your image in the cloud. The Tensorflow.js model, which detects the object within an image. Google File Store, which is a real-time database that we use to store data. And finally, Angular, which is the framework that we are going to use to build this application. But let's see how the flow works in action. Let's say that we have a batch of images that we would like to upload. So what we do? We select one, and with the file storage, we upload this image in the cloud. This means that the next time the user will visit the website, the image will still be there. As next step, we pass this image to the Tensorflow.js model. And you can imagine that a model is like a function. It needs an input, and it will return an output. In this case, the input is the image, and the output is the metadata. Once we have the metadata, we can store this information inside the database. And with that kind of information, it will be easy to filter the image by content. But this is just the theory. Let's see the application in practice. Here, on the left-hand side, you can see our final Angular application. And on the right-hand side, you can see the Google File Storage and Google File Console. I'm showing both of them together. In this way, you can see how the application reacts every time we do something on the database. Here, I'm just uploading a couple of images from my laptop. And you can see that every time I select one, we upload this image in the cloud, and we store the basic information on the database, such as the name of the file and the location of the image in the cloud. For now, we have an empty array that later on will contain the classes within that image. And if we click on the storage, we can see that all the images have been uploaded in the cloud. As the next step, we need to pass this image to the Tensorflow.js. So every time we click on this recognize button, what we do is just taking the image, passing this image to the Tensorflow.js model that will return the metadata. So then we can store this information on the database and even display as label on the UI side. If we click on the item, now you can see that the array contains all the object detected inside that image. And so then we can build just a basic search. So you write the key, and when you click on the search icon, we are able to filter the items based on that key. And as final step, I'm doing the same even for the donuts, just to show you that it's working. And as final step, you could have even a delete button that will allow you to delete the item from both the database and the storage. As you can see, only two documents are left, and the same for the storage. And just for let you know, the pizza doesn't contain any pineapple, just to be. So let's build this application from scratch. I'm using the Angular CLI to create a brand new Angular app. So you can run ng-new with the name of the project. And in less than 1 minute following the preference, you will have an application up and running. The next step is to install the dependency that your project needs. In this case, I'm going to install the Angular File 2, which allows us to use the Angular Store and Angular Storage. So I'm just running npm install with Angular File 2. And we need to do the same to install the Tensorflow.js model that is called CocoSSD. In addition to that, you can even install all the other dependencies, such as Angular material or all the other dependencies that you want. And as a final step, I'm generating a new module. In this way, we could even lazy load this module only when it's needed. Starting from the module, the first step is to initialize an Angular file app. And to do that, we import the Angular file module, and we call this initialize method. And we just need to pass the setting information. And you can pick this information from the Google File Storage console after you have created your project there. Then you can import the dependency that you need, in this case, Angular File Storage for the database, and Angular File Store for the database, and Angular File Storage for the cloud. If you remember the demo, the first step is to allow the user to be able to upload a file. So we generate a new component that is called document task. And we specify the parent module that is the recognition module. And starting from the HTML, we use the input type file that allows the user to upload a file. And every time a file is selected, the change event will fire and the upload function will be called. Just to have a better UI, I'm hiding this tag. I'm using the material buttons that allows me to have a custom icon and a custom sentence. In this case, I'm taking a reference of the previous tag, and basically, as a result, every time I click on this button, as a result, the upload function will be called. So we need to implement this function on the component side. The first step is to take the file from the list. And to be able to upload a file in the cloud, we need the file and the unique ID. For this reason, I'm generating an ID. And so we can start to upload this file. To do that, you need to inject an Angular File Storage dependency inside the constructor. And with that, you can create a new reference, passing the unique ID. And once you have this reference, you can start to upload your file. So if we take a look to the UI, here you have the Angular button. So every time the user clicks, is able to upload an image. And once you select the image, this image will be uploaded in the cloud. If you check the console, you can see that the image now is there. The next step is to save all the basic information, such as the name of the file and the location of the file in the cloud. So here I'm showing more or less the same code as before. The only difference is that I'm taking a reference of the object returned by the put method, that is an Angular file upload task. And this does most of the magic under the hood. And it provides an observable that you can subscribe to that will emit an event every few millihundred seconds that contain the information of the progress of the upload. And because we need just the URL, we need to make sure that the upload is completed. So in this case, this is the reason why I'm using the finalize Rx operator. And so after, we can just call the download URL. And at this point, we have the location of the file in the cloud and all the other information that we need. So we can save this info inside the database. So here, I'm injecting the Angular File Store dependency. And inside the NGRome init, I'm taking a reference of the collection called images. This is just a custom name that you can give to your collection. But once you have that, this is the dependency, this is the collection. Once you have this reference, you can start to insert new document. So I'm passing the same ID that I used before, plus my custom object. And this object contains the name of the file, the location of the file, and for now, just an empty array that later on will contain the object detected within that image. So if we take a look to the UI, starting from the upload, I'm able to select a file. And so once you select the file, we'll upload the file in the cloud. And if we click on this is the file in the cloud. If we click on the database, we can see that the collection images now contains a new document with the information that you just provide, the name of the file, the location, and an empty array. So now we need, the next step is to create a component that is able to show on the UI all the items that we are saving inside the database. So we generate another component, and even in this case, I'm taking a reference of the collection called images. And here, what I'm doing is just merging the information of the object with the ID. In this way, it will be easy for me to just fetch the specific document from the database once the user clicks on that image. On the HTML side, I'm just using a material card to have a better UI, but basically, I'm subscribing to the collection images using the sync pipe. And for each item, we show the name of the image, a preview of the image, all the labels that are inside the array, that at the beginning is just empty. And we have an action that is just a button. And every time we click on this button, we will call this recognize function, and we will pass the information of the object plus a reference of the image. On the component side, this recognize function will call another method that basically will use the detect method exposed by the recognition service. I'm going to show you the implementation of the service in the next slide, but for now, you just need to know that we have a service that is exposing this detect method that basically will accept a reference of the image, and we return all the metadata. This is an example of the metadata, and just for the sake of simplicity, I'm saving on the database the class. But you could save even the other information, such as the position of the object and the score. So here I'm adding this class to the object, and in this way we can update the information that we have on the database. So here I'm taking a reference of the document with that specific ID, and this is why I was merging this information before. And once you have that reference, you can call the update method and just pass in the new information that you want to save. If we give a look to the UI, so you can still upload a file. So we upload the file in the cloud. We save the information on the database. And as you can see, the component reacts and show you a new card with that information. This is a recognition service that is just an Angular service that you can build with the Angular CLI. And if you remember, at the beginning, I said that to be able to use the machine learning, you don't need to know to be able to use a model, you don't need to know how the machine learning works, but you just need to load the model and use it. So let's load the model. First of all, we import the dependency that is the TensorFlow Coco SSD. And as you can see, it exposes a load method that is able to accept different types of models, but all of them are able to recognize 90 different classes. The difference between those is the size and the accuracy of the score that you can get. Once you have loaded the model, you can use the detect method. And this method is able to accept different types, not just an image, but even a video and a canvas. In this case, I'm just passing an image, but you could reuse this code and just start to do detection on a video. And basically, what is happening is that we pass this image to this method, and it will return the metadata. So then you can save this information on the database and display on the UI. Once you have that information, here I'm showing that every time we click on the button, we pass this image to the Tensorflow.js model that returns the metadata, that we store it and we display it. So once we have this kind of information on the database, it's easy just to filter this information based on a key. So here I'm changing a little bit the component that I showed before, and I'm just adding a query parameter. And basically, here, until now, what we were doing is just give us all the items within the collection images. Instead now, what we can do is give us all the items within that image where the class that is an array contains this key, where the query is the key that you write inside the input field, and the class is the array that we store on the database. And just to show you the UI, we can write a key, and every time we click on the search icon, we will be able to filter the items that contain that content. In conclusion, if you are asking yourself, why should I use Tensorflow.js? One reason is, if you have a custom use case, you can build your own model with using Tensorflow.js. This means that you are not relying on an external API, such as the Amazon API or Azure API. And for this reason, you don't have any network latency, so you don't need to wait the request and the response. So you can handle the privacy of the content because the content remains inside your device. And in addition to that, it can work even in offline mode because you don't need to do any external call. Thanks for listening to me. I hope you enjoyed the talk.